Here we go with some Charles Law practice. Now I have the wonderful Charles Law equation right here that shows us the relationship between volume and temperature. Remember, it is a direct relationship, so as temperature increases, volume increases. As temperature decreases, volume decreases. So they're going to increase and decrease together. Isn't that wonderful? Okay, first one, the tires of your car will regularly assume that the tires are filled to a volume of 15.1 liters. It's the thing that we see, and it's measured in liters. So is that a temperature or a volume? It would be a volume, so that'd be V1. At a temperature of 21 degrees Celsius, so that's going to be our T1. Yay. What will the volume become if the temperature decreases to 7 degrees Celsius? So that is going to be our T2. Kind of hard to see there, but what will the volume become? So we are solving for volume. Our V2 is what we're solving for. Now what you should do, then after you get your solution, you come back and watch it and check your answer. That's the purpose here. So make sure you solve this first. So we have our equation here. Our V1 is 15.1, our T1 is 21 degrees Celsius. Let's go ahead and first convert these two Celsius temperatures to Kelvin. So we'd have to do 21 plus 273, so that's going to give us 294 Kelvin for our T1. And then let's do 7 plus 273, and that is going to give us 280 for our Kelvin for our T2. That's the first thing you should always do, is convert from Celsius to Kelvin, so then everything else is straightforward. For our equation, our V1 should have had 15.1 liters. And then for our V2, we don't know, so that's going to be our X. For our T1, we had 294 Kelvin because we converted to Kelvin because we are responsible. And then we come over here and we have 280 Kelvin, also converted to Kelvin, also because we are responsible. So here we go. We can set up our proportions here. 15.1. Boom. Boom. Ah! We're good. Nobody panic. Everything is fine. There we go. Okay. Now we cross multiply and solve. So you go 15.1 multiplied by 280. X times 294. So you should end up with 294x equals, and then we will multiply 15.1 by 280. 15.1 multiplied by 280. This is going to be a big number. 4,228. 4,228. And then we divide, of course. You knew that, right? Yeah, you knew that. You already did this. You already got this question, right? Divide by 294. Divide by 294. 294. 294. So divided by 294. My answer is 14.4. I rounded that, of course. 14.4. What is my answer? What are we doing? Oh, what will the volume become if the temperature decreases to 7 degrees? So that means it's going to be measured in liters. So 14.4 liters. And so we look at that. Let's circle our answer here. Now one thing I want you to notice, the volume decreased to 7 degrees and our temperature decreased to 7 degrees and our volume decreased to 14.4, which means the relationship continues to work correctly, saying that as the volume decreases, the temperature will decrease, or the temperature to the volume, whichever way you want to look at it. Okay, let's go to our next one. Again, you should do this first, then come back and check your answer. The volume of a given gas is 193 milliliters, so that right here is our first thing we identify, and that's going to be our V1. At a temperature of 299 Kelvin, so that right there is going to be our T1. Look how quickly we can identify those. It's like magic. At what temperature will the volume increase to 410 milliliters? So that is going to be our V2, because it's the second volume we've seen, and we are solving for temperature. So first, do we need to convert from Celsius to Kelvin? No, it's already converted. But what do we need to do? We have to go from milliliters to liters. And the best way to go from milliliters to liters is simply to divide milliliters by 1,000. So you do 193 divided by 1,000. And I'm going to check my work on the calculator just to make sure I don't inform you incorrectly, because that would be sad. 193 divided by 1,000. and it's 0.193. So that is our V1 in liters. And then we have 410 divided by 1,000, and that's going to give us 0.410, and that is going to be our V2 in liters. So we have that. So 0.410, and let's move that up a little bit, give ourselves a little more room, and 0.193. So let's set up our ratio. We've put V1 on top, so that would be 0.193 liters. And then we have our V2, which is 0.410 liters. Get all this straight from the problem. Then we have our T1, which is 299 Kelvin. We don't know our T2. That's what we're solving for. This right here. O equals, just like that. Look at that. Victory. Nope, not a victory. I almost said victory and I said it too soon and that jinxed me. Equals, far apart equals sign, but that's just fine. Cross multiply again. You get 0.193x, 0.193, what am I doing? 0.193x equals, and then you do 0.410, 0.410, I got it, don't worry, multiplied by 299, and that gives you 122.6, and then you divide, of course, by 0.193 to get the x by itself. You end up with 635.2 rounded, and we're solving for temperature, so that means it must be in Kelvin, because Kelvin is where it's at. That's where all the fun is happening, is with Kelvin. Right there, 635.2 Kelvin is your final answer. Now don't forget to divide it by 0.193 here. Let's see if it still matches. At what temperature will the volume increase to 410? We see that our temperature increased from 299 to 635.2, so the relationship continues. There's numbers 1 and 2 for your Charles Law practice. Good luck.